Hello everyone, welcome to my channel Cryptoware. So today we are going to solve another reverse engineering challenge, which is this. So I'll share the link and the Crack Me challenge name in the description below. So here you can see that the difficulty level is 2.5 and the quality is 4.7. Again, it is 32-bit architecture that it is having, and it is Windows 1. So here you can see in the description, the goal is to get the right password without patching. So we have not moved to the patching part, which we will discuss later on. But right now, let's start with understanding some basic things that can help you with the reverse engineering. And this is also going to help you with some sort of malware analysis that requires some basic level of reverse engineering debugging as well. But we have done that too before. So yes, so I had already discussed in my previous video like how you can, choose your kind of challenges, the easy level of challenges for yourself so that you can practice. And so let's get started. And again, this is for the beginners level. So I'm hoping that it is of some help to the people, to the beginners who want to get started with this, with reverse engineering. So, first thing first, we will try to understand how this application works. So, we can quickly execute it and we can see that it is asking for password. So, I'll just put any random password and see it says that it's a wrong password. So, we have to find the correct password. So, Alush, I hope I'm pronouncing the name correctly. Apologies if I'm not. So this person has created this Crack Me challenge, which is really very cool. So for this, we are going to use two different tools this time. One would be X32 debugger that we have used previously as well, and along with that, we are going to use Ghidra because we need a disassembler as well to understand what is happening at the code level. So that is going to help us a bit more. And this thing is not very much specific to only this program. You can do this with other programs also. This is going to help you out. So we'll get started with Ghidra. So for running Ghidra, you need to have some JDK dependencies. So once you try downloading Ghidra from their official site, uh, you will get an idea of how it is getting downloaded, what are the dependencies required. I'll share the link from where I downloaded, I mean the genuine website. And for running Ghidra in the Windows, you have to run this ghidra run.bat file. So it will directly start your Ghidra. So let it get started. Before that, we can see how we can see the official website from where you can download Ghidra. So this is the official website. You can see download from GitHub is already mentioned over here. I'll share the link in the description below. You can see this. The releases are already mentioned, and it also has some dependencies, Java dependencies. So I think you'll get it from here. See. Yes, JDK. So here you will see all the details how you can install it. Okay, so I'll share the link. Now moving ahead, let's see if our Ghidra got started or not. Okay, so this is how it's starting. So we'll start with creating a new project. New project. Sure. Next. So you can choose any path, some project directory that you want. I can name the project name as Crackme.2. Now we want to import it. You can directly import it from here, import file, or click on I, and you'll get an option from where you can import the file that you want to analyze. So this is the one. So as you can see, it has given some import result summary. We'll just click on OK and we'll double click on it, and it's launching the tool for us. So it has not been analyzed. So we would like to get it analyzed. So we'll click on yes, and we don't have to choose anything as of now. We'll just go by the default flow. So we'll click on analyze. So the analysis has been done. Now we are going to perform our own analysis. So in the left hand side, you will see program trees where all the headers, sections, everything have been mentioned. And under symbol tree, you will see imports, exports, functions. So from here, we are actually going to go to the functions that we need to analyze. Mostly we go to the entry point, which is this. And from there, we try to follow the next steps that these functions must be following. So it has some startup information, some control FP main arguments, and this is the function that I think is important. Now, sometimes what happens that whenever you are analyzing codes from Ghidra or maybe some other reverse engineering tool, you will find some sort of code which may not be very much linked with your main code, but they are there because they're created during the due to the process of the compilation or for the environment set and everything. So we are not going to talk about that much, but we'll move on to the function that is important for us. And since this is a small program, so it does not take too much time to get to the main function right now, and this is the main function. As you can see, I'm really sorry for the background noise. Yes. So as you can see, this is the same line that we saw when we had executed the application. Now, let us understand the code, what is happening. So as you can see, there are some variables that have been defined. So this buff, this has also been defined. So it actually allocates 20 bytes. So this is 14 in hex, so which is 20 bytes. So it allocates this 20 bytes of memory to this buff variable. Now f get s is actually is something which will read the user input. If you are aware of the C program, then you will know that how this f get s works. So again, it has also mentioned a limit of 20 bytes, which is over here. And if you keep clicking on this, you will see that, sorry, you will see the disassembled code corresponding to it. Now we have this some more variables that have been assigned. You can actually make changes to the rename the variables as well if you want. Like if you want to rename this local 10, you can. So they are like an index basically. So the as you can see, the current index, it starts from 0 here. So it's like if you remember that we used to write C code or any kind of code where for I equal to 0, and then we would set a limit, and then we'll do I plus plus or whatever it was. So it is something like that. You may rename it so that it gets easier or more familiar to you. So if you see, these are some more variables. These are like the indexes that have been assigned. So here the program iterates through each character which have been defined here. So this would be basically the password that we'll be giving. So the maximum amount of memory that we are going to provide here is, sorry, is 20 bytes over here. Okay, so the maximum characters that we are going to put would be 20 bytes over here. So that could be our password, maybe 20 bytes. Let's see if it is like that or not. Now here you will see that some kind of calculations happen which is specific to the input that we are going to put, the password. And there it is going to check for the length of the password, the input that we are going to put. and here the length of it calculates the length using strlen, and it has to be equal to 5. So from here we can understand that the password that we have to put would be of 5 characters. The length would be 5. It cannot go beyond that because there is an and condition over here, and the local c, this index that was checksum, it is most probably a checksum, which is 3b1. If you check it in decimal, it is 945, as you can see over here. So it is 945. So the calculation is such that this local c is being calculated from here. Some calculation is being done over here, where the final checksum should be. The password is calculated in some form over here, which has to be 945 in decimal, and the length of the password should be 5. So this is the code which we are dealing with right now. So the main thing that we have to understand right now is understanding this code, what is happening over here. So now if we try to understand this, suppose let's open notepad and try to understand what is happening over here. So if we consider our buff is a b c d e, then how is the calculation happening? Local c, let's rename local c and local 10 because it is going to help me also. I'll change local 10 to I and see how it gets changed everywhere. Rename it to J so that it gets slightly familiar. Otherwise, it's not required. So, this is the code. So, we'll take it over here. Yes. So, as you can see, this buffer, so it's a kind of array. So, it is iterating through each characters. Okay. So, it is checking for the null character. So, if I equal to 0, buffer I is not equal to this, I equal to I plus 1. So it is talking about the space. So A, 2, 1 would be, because 1 plus 0, I is 0 at this point. Sorry. So how am I calculating this? I is 0. Should be I, sorry. I is 0. So 0 plus 1. Again, if we go to B, I changes to 1 this time. 1 plus 1, 2. So B into 2, and I think it will go something like this: B into 3, sorry, C into 3, D into 4, plus E into 5. And this checksum has to be J, and this J has to be 945. Sorry, this J has to be 945. I hope I'm making some sense over here because I don't want to confuse. So this is what I guess it is following, and if these two conditions are met, you're what you are. You're sober. Okay. Um. Fine. So let's see. So we will try executing the sample using a debugger now. Put it in X32. We'll put it here so that we can keep seeing on what is happening. We'll click on breakpoint. Okay. So we'll move on to, so we'll have to set some breakpoints, like you can click on search for all modules and string references. So you'll see that these are the string references that we saw. So I've already put breakpoint on them, but there are some other breakpoints as well that you can put. That is something that we are going to see while analyzing the code. So if I click on run, it stopped at another breakpoint. So this is the printf. If you remember from Ghidra code, this is that printf. So you can actually relate it from here as well. So the next thing would be this buffer. So you can see EX14. So it is allocating something. So you can actually see all those things happening. It is calling this malloc function. You can see 14 in hex has already been mentioned over here. So this is how you can actually create a connection. Like you can uh, see that how the code is actually working, how it looks, how the actual code actually looks, and how it looks in the assembly language. So we'll move into step into call function. We'll see what it is doing. So yes, here is string length and everything. I don't think we require a lot of things. So this is the printf. So after it gets executed, mostly we should be able to see something on the screen. And so why am I doing step over and step into mostly? Because I want to get through what is actually happening. Okay, there are a lot of other things that are important at this point. So yes. So as it says, the password has to be of length minimum I mean 5, but the buffer allocated is 20. So we can do one thing. Let us put the password and see how it behaves. So allocation is actually happening right now. And this is the fgetters. Now it will be able to take our input. See, till now I'm not able to type anything. Okay, but once I click on this fget I should be, yes, able to add something. It is able to take some input. So I will take track me test. So it is of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It is of 11 characters. And anyway, it is more than 5. So it should not be, according to the condition. But we'll see how it behaves. So we'll click on enter. And here we'll just keep going on step overs and step intos, and we'll see how the calculation is happening. So after doing some step overs and step intos, so basically it was kind of adding it, it was taking it as an input and putting it into the buffer space that was assigned, I mean allocated. Now we are at this point where this crack me test is being moved to EAX. So we'll keep an eye over here. EAX is being pushed onto the stack, so we'll be able to see it here as well. Again, I know that we did not discuss about stack and assembly before, but we will discuss about this. But these are at the very basic level. So right now, even if you follow what I am doing over here, that is also going to help you to a certain extent with the analysis. And then it is going to call str length. So here it is going to check the length of the input that I have given. So we'll just move, and you can see that in EX we have crack me test. We'll move slightly ahead, and this time we can see that it has been pushed onto the stack as well. Now we'll do step into, because we want to see the comparison. Another thing that I would like to show you, that CMP is used for comparison. So before that, it is taking 4 to the stack pointer. So I'm slightly thinking what is it going to compare. Okay, we will see. So in the call, it is going to, sorry, in this function, it is going to calculate the length of the string that I have provided as an input. And then later, so in EAX will be having the length of the string that I have provided as an input. And these two will be compared against each other. Okay, so let's see how it is happening. So we'll step into and we'll see it is going to uh, check. In the EAX, we'll have to keep an eye because it is going to show us the length. So here it is. So we'll have to do a number of step intos and step overs again. ECX 4. So since it is taking as 4, I think I think the password that we have to provide should not be 5 as well because of something that I had guessed before. But that is fine. Um, Now let's see the value of EAX at this point. The EAX value is C. So 11, yes, decimal it is, if I'm not wrong. It is adding 4 to the stack pointer, ESP, okay. It's the comparison is being made EAX against 5, which is not equal to. So if jump not equal to, it'll move to, I think you have given a wrong password. Okay. But again, if you see this code, if I bypass this somehow, because if previously you have known that changing the zero flags can actually help you bypass this. But if you do this, you'll have another check, which is this check that we discussed about. I guess this is getting slightly complicated, but don't worry, we'll try to understand that. So there are two checks that I have already mentioned in Ghidra. So in okay, yeah. So one check is this compare EAX against 5, which is over here. This svar1 has the value, the string length, which is present in the EAX over here. And this J is 3B1, which is 945 in decimal. I guess it's 945, right? Yeah. 945. This is what is getting compared over here. So again, this is EX. Of course, the value is getting changed because here some calculations are happening at this point as well. So we can bypass that, but we are not going to. We'll just see how the comparison is happening. So it's comparing EAX and 5. And yes, it is jump not equal to. But suppose if I bypass this, like if I click on the zero flag, jump is not taken, and we move to this. And within this compare option also, we have bypassed this part, the comparison of the string. But there is this another comparison that we have mentioned that we saw in Ghidra as well. And here is another jump. And even if you bypass this, we'll be able to get this good job, you're sober. Okay, let's see if we are getting that. Yes, but this is something that we have bypassed, as in the um, as it was mentioned in the Crackmes that we want to get the right password. Here you can do some kind of patching as well, which we are not going to do right now. We'll learn about patching later on. But this is one of the way that we have followed previously as well, and this is followed by in a number of cases. Sorry for the noise. Yes. So this is not we want to follow right now. We want to guess the password. We want to know what is the right password. And few other things that we have observed is like we have to provide this input of 5 length. Let's see what happens when we provide A, B, C, D, E right now. Let's, let's move to the entry point. The breakpoints are already set. Will this time quickly go so that we can move here. I hope this is just a print F. So, so um, so crack itself is a 5 letter word. So let's put crack over here. I'll click on enter and yes. Sorry, it got selected. So push EAX, it's going to compare the string length. This time, what we are going to see is again the comparison will be happening. Our EX should be having 5 as the length. So again, let's step into and let's see what's happening. Add ECX to 4. Okay, 4 is being added to ECX and jump equal to K. K is already left over there. Okay, if this is something that you observe, CRACK/N, mostly it is taking uh, slash N as the complete password over here, along with that, mostly. So, if that is the case, we are not going to get the uh, correct result. I mean, the comparison with the 5 thing is something which we thought that we would be able to bypass, or we have given correct condition, will not be able to do. Let's see. So this time the EAX is 6, which was supposed to be 5. So if slash n is considered to be the next character, then it becomes 6. Okay. So that is the reason we are not able, we will not be able to get this correctly. So let's again restart, and this time we'll put 4 characters. I hope you all are with me on this. Let me just, this time I'll just put 4 letter words. Okay, PASS. Okay, sorry, I have to. PASS is the one. And if we are considering slash n as the password along with PASS, then it should be 5. So let's see if this time we are going to get 5 in value in the EAX or not. ECX has always made me think that the value of 4 getting added, something is happening, something is very fishy. But anyway, let's see. And this time the value of EAX is 5. So our password has to be 4 letter, including this slash n. Sorry, where is this? So we have to be worrying about only this. And this is something, this E has to be always, okay, sorry, slash n. So we have found that till now we have understood that the final character is slash n. So according to this logic, we have to put the ASCII value of slash 10, which is 10. And as you said, as you saw that it is getting multiplied with the number according to its position. So it will be 5. So into 5 would be 50. So we have to worry about this. So basically, for such kind of scripts, like for such kind of programs, it is always advisable to write scripts, because I don't think it is possible to uh, do it manually. Here we have two conditions that the string, the password is of 4, of length 4, followed by new line character, so which makes it a 5 length of password, and the checksum has to be 945, which should be following something like this. So you already know the logic, so we can directly run the code. I'm not sharing the code as of now in this um, over here, but let me know in the comments if you need the code. I'll definitely share, but we already know the logic, so you can try writing a Python or whichever language you're comfortable in, a code of yourself, so that you can actually you know you can actually run it by yourself and find the password. So if I want to write, so if we again run this code, this program, let's see. And here you see that it is asking for a password. So I already have a code. As I mentioned, I'm not going to share it right now. We already know the logic, so I would want you to try it by yourself, and then maybe we can discuss about it later on. Uh, we can discuss about the code as well later on if required. For now, we know the logic, so I would want you to try to write a simple Python code on your own. So I'll just, it's not necessary to be written in Python. You can choose any program of, I mean, any language of your choice. I'm more comfortable with Python. So I've used this code. This is the password. And I'll just paste it over here. And we have to make sure that the final uh, character has to be the next line and nothing else. So here you can see that it ends with slash n, and we'll click on run and see that we have reached to this good job, because we have successfully passed this part as well, where it is checking against 945 in decimal. Yes. I hope it made some sense. I hope I was able to understand, make you understand. If not, please let me know. Just for clarity, let's go through the entire process again. So we opened this program in Ghidra to understand the decompiled code, from where we can actually understand what the code is doing, instead of directly jumping into a debugger. Although we can do that as well, but even after doing that, I would suggest that we'll have to go through this, so that it gives us more clarity, instead of uh, spending too much time on identifying everything from the debugger itself. So if you can use two tools and get a clarity, that would be better. So from here, we understood that although it is taking 20 bytes as the buffer input, but the password length has to be 5. The conditions are already there, and there is some sort of calculation that it is doing over here, which we have already seen here how it is happening. So it's kind of checksum that is happening should be equal to 945. So if we could meet both the conditions, which follows this condition, then we'll be able to get the password. And that is what we tried to achieve while executing the sample through the debugger. Now in the debugger, we observed that the 5 characters that we were putting, the length of the password was 5. The fifth character is supposed to be the next line, and not any other character or any other character over here. It has to be the next line, because here you can see how it is taking exclamation, exclamation, d, and this bar, I guess, this character, and slash n as the entire password. And this is how it is counting the length of the entire password or the entire string over here. So slash n has to be there. Since we know slash n, the next line character is the password over here, which is the fifth character. So according to the logic that we saw, this last one, it was e initially, this e has to be the ASCII value of next line character, which is 10, and multiplying 10 with 5, because it is the fifth character, we got 50. So we have gotten 50 over here, and we needed to find the next first four characters of the password. And that is why we wrote a script which would be performing the same thing for us, so that we can find what could be the possible password. So the script would break the first time it gets a password, but if you do not want to break, you can try gaining all the passwords, and you'll finally see that all the passwords are working, as long as they are able to fulfill these two conditions. I hope I'm making some sense. Please ask me any questions in the comment section below. If you have any doubt, any question, I know this could be slightly difficult, but that is fine. If you have any question, I'm ready to explain and answer all those questions as well. If you have any doubt, if you have not understood anything from this part, or what you can try doing is, I'll put all the details of this challenge in the description below. You can try it all by yourself, and maybe while trying to replicating the things the way I have done over here may help you. So thank you so much for supporting me. Please like, share, and subscribe to my channel. And let's see, we'll come up with more amazing videos on malware and reverse engineering, and we'll jump from the beginners to slightly intermediate to advanced level as well in the future.